In this episode, we're going to make cloud and virtualization scoping feel like something you can reason through calmly, even when the environment sounds complicated and full of moving parts. When beginners first hear that an organization runs payment systems in the cloud or on virtual machines, it can feel like the assessment becomes mysterious, as if the data is floating somewhere you cannot see. That uncertainty is exactly where scope mistakes happen, because people either assume the cloud provider handles everything, or they assume everything connected to the cloud must be included. Neither extreme is professional, and neither extreme produces a defensible result. The goal is to learn a practical way to identify what is in scope, what is out of scope, and what evidence is needed to support those conclusions in cloud and virtualized environments. Once you have that mental method, you can approach questions and real scenarios with confidence instead of guesswork. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A solid starting point is remembering that scope is not about where servers live, but about where payment data lives and what can impact its security. The cardholder data environment, CDE, is still the same concept, whether systems are on a physical server in a closet or on virtual infrastructure in a large provider data center. The difference is that cloud and virtualization change how boundaries are built, how responsibilities are shared, and how you confirm what is true. The same scoping logic applies. You trace data flows, identify connected systems that can impact security, and define boundaries that are enforced rather than assumed. What changes is the visibility and the control surface, because you may not touch the underlying hardware, and you may rely on provider-managed components you cannot directly inspect in a traditional way. That does not mean you have less responsibility to be precise. It means you must be more deliberate about understanding who controls which layers and what evidence proves those layers are secured. When you internalize that shift, cloud scope becomes a structured reasoning task instead of a fog. To navigate cloud scope like a pro, you need a clean model of shared responsibility, because it is the first place beginners get trapped. A cloud service provider, CSP, usually controls the physical facilities, the physical network, and the hypervisor layer, while the customer controls some combination of configurations, identities, operating systems, applications, and data. The exact split depends on the service model, but the practical point is that the customer always retains responsibility for protecting card data and proving controls are effective in their portion of the stack. This is where people create blind spots by assuming that a provider compliance document automatically covers their own configurations and workflows. A qualified security assessor, QSA, will look for clarity about which party performs which security tasks and what evidence demonstrates those tasks are actually done. If a control is provider-managed, you need evidence of that provider management and evidence that the control applies to the service you are using. If a control is customer-managed, you need customer-side artifacts that show it is working. Pro-level scoping starts with that responsibility map. Virtualization adds another layer of complexity because it introduces shared infrastructure inside an organization's own environment, even when the organization is not using a public cloud. A virtual machine VM is a logical computer that runs on shared physical resources, and that shared nature is where scoping and evidence questions become more subtle. In a traditional environment, you might assume that each server is a separate box with a clear boundary, but in a virtual environment, many VM systems can share a host and a management plane. The management plane is the control surface used to create, configure, and administer those VM systems. And if that management plane is broad or poorly controlled, it becomes a powerful pathway that can impact the entire CDE. This means scoping must consider not only the VM systems that store, process, or transmit card data, but also the systems and accounts that can administer them. A common beginner mistake is to scope only the guest systems and ignore the virtualization infrastructure that controls them. A pro-level approach treats administrative influence as scope relevant, because influence is often more dangerous than direct data access. Once you have the shared responsibility mindset, the next pro move is tracing payment data flows in cloud and virtual environments without assuming that the data stays where you think it should. Cloud services often introduce new paths automatically, such as backups, snapshots, replication across zones, log aggregation, and managed monitoring, and those paths can carry sensitive data or metadata that affect scope. In virtual environments, data might move through shared storage systems, backup platforms, or administrative tools that copy images and configurations for convenience. A scoping mistake happens when an organization focuses on the primary transaction path and forgets these secondary operational paths. For example, even if card data is handled only by an application, the application's logs, error dumps, or support exports can include sensitive values if the system is not carefully designed. When those artifacts are shipped to centralized logging services, your scope story changes because now additional systems and access paths are involved. The professional habit is to ask not only where the data is used, but where it is replicated, retained, or observed by operational services. When you trace those paths early, you avoid surprise scope expansion later. In cloud and virtualization, boundaries often look different from traditional network diagrams, so you need to get comfortable evaluating boundaries in terms of isolation and control rather than physical separation. In a cloud environment, segmentation may be implemented through virtual networks, security groups, access policies, and service endpoints, and the key question is still whether unauthorized systems can reach the CDE or influence it. In a virtualized data center, segmentation may be expressed through VLAN design, internal firewalls, and controlled administrative zones. And again, the question is whether the CDE is meaningfully isolated. The danger is treating logical constructs as inherently safe, simply because they are labeled as separate. A pro-level mindset treats a boundary as proven only when you can demonstrate that connectivity is limited, administrative paths are controlled, and exceptions are managed deliberately. This is where evidence discipline matters, because the environment can be complex, and it is easy to trust a diagram that does not reflect current reality. The stronger your boundary story, the smaller and more defensible your scope can be, but only if the boundary is real and maintained over time. Identity and access control become even more central in cloud and virtualization scoping, because control planes are often reached through identity systems rather than through physical proximity. If someone can authenticate into the console or management interface that controls cloud resources or virtual hosts, they can often change network rules, create new systems, or modify logging and monitoring settings. That means identity systems, privileged accounts, and access workflows can be scope impacting even when they are not traditionally considered part of payment processing. A beginner mistake is to view identity as a separate topic from data scope, but in these environments, identity is one of the primary ways an attacker would move from a non-payment system into a payment system. A pro-level approach asks who can create resources, who can change security settings, who can access sensitive storage, and how those privileges are approved, reviewed, and revoked. It also asks whether access is centralized and consistently enforced, or whether exceptions exist that bypass normal controls. If privileged access is broad, your scope expands because more systems can influence CDE security. If privileged access is tightly controlled, your scope story becomes cleaner and more defensible. Another area where professionals avoid blind spots is understanding how multi-tenancy and provider-managed infrastructure affect what you can and cannot verify directly. In many cloud services, the customer cannot inspect the underlying host security because the provider manages that layer, yet the risk of shared infrastructure still exists conceptually. This is not an excuse to accept unknown risk. It is a prompt to gather the right kind of provider evidence and to verify that the chosen service model is appropriate for handling payment data. A third-party service provider, TPSP, relationship needs governance, and in cloud environments, that governance includes understanding which provider attestations apply, what scope those attestations cover, and what responsibilities remain on the customer side. A pro-level assessment does not treat provider documents as magic shields, but it does use them appropriately to support conclusions about provider-controlled layers. The customer still must demonstrate that their configurations, access controls, and data handling practices meet the requirement intent. When you can clearly separate provider layer proof from customer layer proof, you reduce confusion and produce reporting that stands up to review. Virtualization also introduces scoping challenges around shared services like storage, backups, monitoring, and patch management, because these services often span both in-scope and out-of-scope environments. If a shared backup platform can access or restore CDE systems, that platform becomes a pathway of influence and may need to be considered in scope. If a shared monitoring system collects logs from the CDE, the question becomes what those logs contain, who can access them, and whether access is controlled appropriately. If patch management tools push updates into the CDE, the management infrastructure and its access controls become relevant because compromise there can compromise the CDE. Beginners sometimes assume shared services are harmless because they are internal utility systems, but professional scoping treats them as critical connections that can strengthen or weaken boundaries. The pro move is not to declare everything in scope, but to analyze each shared service as a potential bridge and determine whether it is controlled enough to preserve segmentation. Sometimes the right answer is dedicated tooling for the CDE, and sometimes the right answer is tight access boundaries and strong monitoring, but the decision must be evidence-driven. Cloud environments also have a habit of creating hidden expansion through convenience features, and being pro-level means anticipating those features in your scope reasoning. Automatic scaling can create many instances that must still follow the same security configuration, which changes how you think about evidence and sampling. Managed services can handle patching and maintenance, which changes where you look for proof, but it does not eliminate the need for proof. Infrastructure templates can create consistent builds, which can strengthen sampling defensibility, but only if you can demonstrate that templates are controlled, reviewed, and used consistently. Logging pipelines can centralize visibility, which can improve security, but they can also centralize sensitive data if logs are not filtered or access is broad. A pro-level scoping mindset treats these features as both opportunity and risk. Opportunity exists because automation can improve standardization and reduce drift, and risk exists because automation can replicate mistakes at scale. When you evaluate these dynamics honestly, you can justify a scope that reflects real control maturity rather than assumptions. Evidence strategy in cloud and virtualization must match the reality that you may have different types of artifacts than in traditional environments. Instead of relying on physical inspection, you often rely on configuration states, access policies, change records, and monitoring evidence that shows how the environment behaves over time. The key is still triangulation, meaning you do not rely on a single artifact type to prove a control. If an organization claims segmentation, you want evidence that the logical segmentation rules exist, evidence that those rules are controlled through change processes, and evidence that the segmentation is effective in limiting unauthorized paths. If an organization claims privileged access is restricted, you want evidence of role assignments, evidence of approval workflows, and evidence of periodic review. If the provider manages certain controls, you want provider-side proof that those controls exist and apply to the service, and customer-side proof that the customer-configured layers are aligned. A pro-level evidence strategy anticipates what can drift, such as identity permissions and network rules, and focuses on proof that detects and controls drift. This approach makes your conclusions harder to challenge because they are anchored in observable behavior rather than static claims. A common beginner pitfall in cloud scoping is overscoping due to fear, which can happen when the environment feels too abstract to understand. Overscoping can waste effort and blur the assessment by pulling in systems that have no meaningful influence on the CDE simply because they are connected in some vague way. The professional response to abstraction is not to widen scope blindly, but to identify the specific influence pathways that matter, such as administrative access, network connectivity, shared identity systems, shared logging access, or shared deployment pipelines. If those pathways are blocked or tightly controlled, you may be able to justify a narrower scope. If those pathways are open or poorly governed, the scope must expand, but it expands for a reason that can be explained and defended. The pro mindset is comfortable with either outcome, because the goal is accuracy, not minimalism and not maximalism. When you can explain precisely why a system is in scope or out of scope, you remove anxiety from the decision and replace it with defensible logic. Virtualization introduces another pitfall, which is assuming that, because a virtual environment is internal, it is automatically simpler than cloud. Internal virtualization can be just as complex, especially when different business units share the same hosts, networks, and management tools. If the CDE shares the same virtualization hosts as out-of-scope systems, you need to understand whether separation is strong enough at the management layer and network layer to prevent cross-impact. If administrators can manage both environments from the same workstation and credentials, that administrative plane may become scope-relevant. If the virtual switch configuration and routing allow traffic between zones, segmentation claims may be weak. Professionals also pay attention to how images and snapshots are handled, because moving virtual disks and templates can create data handling paths that were not expected. The goal is not to fear virtualization, but to treat it as a shared infrastructure model that demands careful control of management access and data artifacts. When you respect the management plane and the storage plane as scope drivers, you prevent the most common virtualization scoping mistakes. A pro-level approach also includes being able to explain cloud and virtualization scope to stakeholders in a way that reduces conflict and increases cooperation. Many stakeholders want a simple answer like the provider handles it or our cloud is compliant, but those phrases are too vague to support a defensible assessment. The QSA role is to translate complexity into clear responsibility statements and clear evidence expectations, without overwhelming people with technical detail. That might mean explaining that the provider manages the underlying infrastructure controls, while the organization must manage identities, configurations, and data handling, and that both parts need evidence. It might mean explaining that segmentation in cloud is real only if policies and access paths enforce it consistently, and that shared services must be evaluated as bridges. When stakeholders understand the reasoning, they are more likely to provide accurate information and the right artifacts, and they are less likely to interpret scope decisions as arbitrary. Clear explanation is not a soft skill add-on in this world. It is part of producing assessments that stand up because it helps align reality, evidence, and reporting. To conclude, navigating cloud and virtualization scope like a pro is about applying the same core scoping logic with extra discipline around shared responsibility, management planes, and hidden operational data paths. The cardholder data environment, CDE, is still defined by where payment data lives and what can impact its security, but cloud and virtualization change where control surfaces exist and who controls them. Pro-level scoping begins by mapping responsibilities between the customer and the cloud service provider, CSP, then tracing data flows through primary and secondary operational paths like logging, backups, and replication. It continues by evaluating boundaries as in forced isolation, not as labels, and by treating identity, privileged access, and shared services as key drivers of influence and scope. Strong evidence strategies triangulate design and effectiveness across both provider-managed and customer-managed layers, while avoiding overscoping driven by fear or underscoping driven by assumptions. When you can articulate influence pathways and match them to evidence, cloud and virtualization stop being confusing and start being a structured assessment problem you can solve with confidence.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.